Cell phones. No longer are they just that thing your kids pay more attention to than they do you. No, as a matter of fact, they've become so ubiquitous, you can find them on gated communities, apartment complexes, and even high-end homes. As a matter of fact, cellular access control is becoming the fastest growing market in the perimeter access control sector. This is happening in large part because of just a few key reasons. First, there's less wiring involved. You no longer have to worry about someone or something damaging the home run from your phone system back to the property's demarc box. You just need a power source and a few relay wires to get up and running. Second is cheaper phone plans, at least for commercial applications, which can run upwards to $400 a month, depending on the location and usage. Most of the cellular phone access control systems can handle the same application for as little as $50 a month, making this a huge upsell to your customer. Lastly, they offer a reliable connection pretty much wherever you are. It's that last point that's not entirely accurate. While cell phone coverage has improved over the years and can be found in most areas, it doesn't mean it's always there. Most of the problems people face when dealing with cellular access systems is actually related to poor signal strength. Even today, you'll find that there are dead zones all over the place. Even in densely populated areas, you may have little to no signal. While that typically isn't a major issue for your average cell phone, it does become a sticking point for your customer when that expensive phone system they just paid for doesn't always work. So what actually constitutes a good signal strength? Well, depending on who you ask or where you look, you're going to get a different answer. For the most part, it seems to be that so long as the connection remains intact, it's a good call. That doesn't necessarily work for us, nor does it work for your customer. Let's put it this way. If they're having cellular issues, they're not going to call AT&T or T-Mobile or whoever the provider is. They're going to call you. Now, because of that, we at Encon Electronics take a bit more of a hardline stance when it comes to our signal strength readings. We look at the reference signal received power, or RSRP, and make our determination based on that. We want to see somewhere between negative 45 decibel milliwatts and negative 80 decibel milliwatts to ensure a reliable installation. Generally speaking, between negative 85 and negative 95 decibel milliwatts is good enough. However, it can enter the unreliable range fairly quickly depending on tower traffic. Anything north of 100 decibel milliwatts and you're asking for trouble. Granted, there are some booster antennas you can install, but that's not always going to solve your problem. Now you may be asking if 85 to 95 decibel milliwatts is good enough, why isn't it good enough for us? The reason is that if our cellular towers near the installation receive spikes in data requests, then our RSRP value is going to change depending on that influx of traffic. This in turn may result in our phone system experiencing connection issues. Let's say that there are 3 towers near your installation. If suddenly one of those towers goes down for maintenance or is damaged, then all the traffic that the tower was handling is going to have to redirect to the other towers around it, which means that the RSRP value you had before is going to change. How badly it will suffer, well, that's going to depend on how much traffic is being redirected to your tower. The other thing you may need to take into account is if there are any schools, freeways, or malls nearby, as those can be network hogs that suddenly and temporarily soak up all that good RSRP, leaving your system thirsty and your customer upset that the unit is randomly not working. Informing your customer of these potential issues and educating them in advance can oftentimes reduce your callbacks. Now that we know what to look for, let's discuss what you should be doing before you install a cellular entry system. Every cell phone has a built-in cellular network tool that you can use to check your network signal strength. Mind you, this only applies to that phone's cellular network, so you want to make sure it uses the same provider as the system you'll be installing. Let's start with an Android, the far superior operating system.
You'll want to tap on Settings, then navigate to About Phone. From here, you'll want to find Status or Network. Tap on SIM card status. Here, you should be able to find your decibel milliwatts labeled as signal strength. It's as simple as that.
Now let's say you have an iPhone. Why First, you want to dial star 3001 pound 12345 pound star, and then you're going to want to call that. This will give us access to a hidden area in which we can see the network cellular information. For AT&T or T-Mobile customers, you'll then tap on LTE. Now, tap on Serving Cell MEAS. MEAS, I think? Your decibel milliwatts will be next to RSRP 0. For Verizon or Sprint, you'll tap on 1XEV-DO. Your decibel milliwatts is read as RXAGC0. I believe newer iPhones vary in this procedure just a little bit, but I don't know anybody with anything past an iPhone 7, because Androids are better. But if I happen to find somebody with an iPhone 10 or something like that, I will definitely stitch that video right on in here.
Alright, so I was able to find an iPhone 10. Looks like it doesn't matter what carrier. You still call the number, but this time you actually go to Serving Cell Measurements, and the RSRP value is right here. They also have the RSRQ, but we'll go over that in the next video.
If you happen to have an older iPhone with an operating system pre-iOS 11, I believe all you have to do is swipe down on the notification bar, and then your decibel milliwatts should be read in the upper left-hand corner of your screen. Not exactly sure why they made it so much easier on the older iPhones than the newer ones, but it is what it is. Now that you know what to look for, make sure that you check the site before agreeing to the installation. We also recommend performing multiple tests while at the site at different times or even different days, so that you can see what the typical reading should be for that particular site. If possible, have your customer try this a few times during the week and record what they get. This way, you can go into the job knowing that the cellular access system will work. Just be sure that the phone you're testing this with is using the same service provider that the system you're installing will also be using. Let's talk power consumption, specifically solar consumption. Cell units are not solar friendly, despite what some may say. The key reason is because when cell signal drops, the unit tends to pump more power into the antenna in an attempt to capture some of that signal out of the ether. Some cell units can guzzle up to 2 amps during this process. That means in an area with really bad cell reception, you can see upwards to 48 amps a day pulled from your system. Depending on where the job site's located, they may need north of 320 watts for a 12-volt system or 640 watts for a 24-volt system. That's massive. Now, granted, this is an extreme situation that you'll never run into, but for this reason, we at Encon Electronics do not recommend using a cellular system on a solar application. Don't get me wrong, it can be done, it's just not recommended. We'll talk more about solar in a future video. Hopefully this video has helped you understand cellular a bit more, and just maybe you won't have to deal with any problem jobs in the future. Thanks for watching, and see you next time.